Good morning, sir. Myself, Akash, and studying mechanical engineering second year in SRIT Institute. Today, I want to discuss the topic about recyclability and self regulation in nature. Introduction to recyclability and self regulation. Recyclability refers to the ability of materials to be processed and reused. Self regulation in nature refers to the systems maintaining balance and sustainability. Together, these concepts illustrate how ecosystems function efficiently. From the figure, we can observe the process of recycling, ways we can recycle, and what is recycling, why do we recycle. Let's see ways we can recycle. Bringing water bottles to glass, recycling paper, reusing magazines for projects. What is recycling? Using materials that have already been used and reusing them. Why do we recycle? Good for the environment. Use less raw materials. The concept of recyclability. Recyclability is a crucial for reducing waste and conserving resources. Many materials such as paper, glass, and metals can be recycled repeatedly. Understanding recyclability encourages responsible consumption and waste management. In the figure, there is source reduction first: reduce, reuse, recycle or composite, energy recover energy from waste, dispose, and landfill. Natural recycling process. Nature has its own recycling systems such as decomposition and nutrition cycling. Decomposers like fungus and bacteria break down organic material, returning nutrients to the soil. These processes ensure that ecosystems remain healthy and productive over time. In figure, we can observe that the biosphere, photosynthesis, and soil respiration, which takes carbon dioxide, and the soil respiration carbon dioxide is released into the atmosphere. And strategically grazed animals promote carbon dioxide sequestration in the soils. Grass regenerates and is ready for grazing. The carbon will be sequestered again when the animals return. Soil organic matter, decaying organisms are made of carbon. Roots are made of carbon that once came from the air, and grass roots contain carbon. When the grass is eaten above ground, the roots are released in the soil. Taking stored carbon from fossil fuels. Examples of natural recycling. Forest recycle nutrients through leaf litter decomposition. Wetlands filter water and recycle nutrients, supporting diverse wildlife. Coral reefs recycle nutrients and provide critical habitats from marine life. Mm, in figure, the water and air penetrate soil. How is it possible? Means um, plant animal matter breaks down into soil. The decomposers break down the organic matter. The soil stores nutrients which plants absorb, and the nutrients used to grow. Self-regulation in ecosystems. Self-regulation refers to the ability of ecosystems to maintain balance and stability. Populations of species naturally fluctuate in response to environmental changes. This balance allows ecosystems to recover from disturbances and thrive. There are 5 steps of self-regulations. One, the reframe the behavior and recognize stressors. Respond, reflect, enhance stress awareness, reduce stressors. And respond is the develop personalized strategies to promote resilience and restoration. For more information, feedback mechanisms in nature. Feedback mechanisms help ecosystems self-regulate by responding to changes. For example, predator-prey relationships stabilize animal populations. These interactions ensure that resources are used sustainably. The role of biodiversity. Biodiversity enhances ecosystem resilience and self-regulation. Diverse species fulfill various roles, contributing to nutrient cycling and energy flow. Healthy ecosystems are less vulnerable to disturbances and environmental changes. From the figure, we can observe the what is the biodiversity. Biodiversity refers to the diverse kinds of living things in the given area. Human impact on natural systems. Human activities often disrupt natural recycling and self-regulation process. Pollution, deforestation, and overfishing can lead to ecosystem imbalances. Understanding these impacts is essential for promoting sustainability and recovery. Coupled human and natural system. Human, there are sectors, stakeholders, and organizational levels. And in nature, there is biotic and organizational levels. The importance of sustainable particles. Sustainable practices aim to reduce negative human impacts on ecosystems. Recycling, conservation, and renewable energy are vital for sustainability. These practices help restore natural recycling and self-regulation process. There are top 10 ways to live a more sustainable life. First, the turn off the faucet. The average American household uses 300 gallons of water daily. Cut back on single-use plastics. And second is invest in Energy Star appliances. For example, an Energy Star washing machine cost $143 less to run annually than an older model. And the third one is cut back on single-use plastics. Each year 150 million tons of single-use plastics are produced worldwide. Fourth is recycle the right way. Wash and dry cans and containers before tossing them in recycling bin. Food can contaminate an entire bin and render it unrecyclable. The fifth one is upcycle. Look for creative ways to use old things. For example, yesterday's t-shirts can become today's cleaning racks. And the sixth is take steps to reduce food waste. 40% of all food is wasted in the US, so aim to use your leftovers, freeze excess ingredients, and shop smarter. Seventh way is eat local whenever possible. Food that doesn't need to travel takes less energy to get to your plate. And the eighth way is eat more meatless meals. It takes more than 3 times the water to produce a pound of beef as it does a pound of desired beans. Ninth way is shop smarter. Only buy clothing if you anticipate wearing the item a minimum of 30 times. The 10th is drive less. A typical vehicle emits 4.6 metric tons of carbon emissions annually. Case study: the carbon cycle. The carbon cycle is a critical natural recycling process that regulates climate. Carbon is stored in plants, soils, and oceans, cycling through various forms. Disruptions to this cycle can lead to climate change and ecological imbalance. We can observe the flow chart of the carbon cycle. The carbon dioxide is formed from the photosynthesis and the organic carbon, animal respiration, ocean uptake, plant respiration, dead organisms, and waste products, root aspiration, which are the fossil fuels, mineral carbon, and factory and vehicle emissions. Urban ecosystems and recyclability. Urban ecosystems can implement recycling practices to enhance sustainability. Green spaces and urban gardens contribute to local biodiversity and nutrient cycling. Urban planning can incorporate self-regulating systems to improve environmental health. Education and awareness. Education about recyclability and self-regulation is crucial for future generations. Awareness campaigns can promote responsible consumption and waste reduction. Empowering individuals fosters a collective effort toward environmental stewardship. In the figure, there are 10 amazing facts about recycling. One is, once an aluminum can has been placed for recycling, it can be back on the shop floor in 3 weeks. Enough metal was recycled from old corsets to build 2 warships. Recycled gold is donated to charity in Japan from discarded centuries. Old CDs are used to lay roads. 2010 paper recycling had increased over 89% since 1990. 6 billion bottles and jars are used each year. It would take over 3,500 years to sink 6 billion green bottles. In the USA, 80 million dollars is wasted from the scrapping of precious metals in their old phones. Recycling 100 cans could light your bedroom for 2 whole weeks. Sports brands will recycle the rubber on old running shoes for tennis courts and running tracks. Over 75% of waste is recyclable, but only recycle about 30% of it. Technological innovations in recycling. Advances in technology improve recycling processes and materials recovery. Innovations such as biodegradable materials reduce reliance on traditional recycling. Smart systems can optimize waste management and enhance self-regulation in cities. There are top 8 plastic recycling trends and innovations in 2022. Plastic recycling as pyrolysis, recyclates, innovative depolymerization, advanced gasification, advanced mechanical recycling, plastic traceability, automated recycling, solvent-based purification. Startups and emerging companies analyzed Data provided by Start Insights in June 2022. Policy and regulation. Effective policies can support recycling initiatives and ecosystem conservation. Legislation can enforce recycling programs and protect natural habitats. Collaboration among governments, businesses, and communities is essential for success. Conclusion. The interconnectedness of recycling and nature. Understanding recyclability and self regulation helps us appreciate nature's balance. Sustainable practices are essential for maintaining healthy ecosystems. Together, we can foster a harmonious relationship with our environment.